Okay, this is problem number 41, and the problem reads, how close does the curve y equals square root of x come to the point 3/2, comma 0? So 3/2, 0. And the first thing you might want to do is get a sketch of this in your head, or I'm just going to pull up our calculator and we'll literally get a real sketch of this. So let's take a look here. Let's go to our graph. Let's graph the square root of x, and I know you know what that looks like, but let's just get it in here anyway. Square root of x. And for a window, we're certainly in the first quadrant, so x will go, a little negative, negative 0.5. We'll come out, we have the point 3/2, so let's come out maybe to 3. And count by ones is fine. The y-min, same thing, we're in the first quadrant, so negative 0.5 should do it. And it's just square, negative 0.5. And then the square root doesn't grow as quickly, so y max, let's go with 2. Okay, so here's our graph, and we get this here. Let's just save that graph so we have it. I'm going to lock that in place. And now we've got this. Okay, so this is our graph. This is our graph y equals the square root of x. And now we've got the point 3/2, 0. And the question is, how close does the curve come to the point? And your first guess might be, well, to get as close as possible, why don't I just draw a line straight up? And you might be right, or you might be very close, but you have to consider maybe we should go just a little bit to the left. And that might give us a point slightly closer than if we go straight up or down. And we're going to figure out exactly where this point is at in a minute, but at least maybe you're thinking about it and thinking it's not as simple as just going straight up and down. So let's call a point on our curve. Let's call that point xy. We can sketch a line segment in here joining the 2 points. And we also know as we sketch this, we have our point xy, but we know y equals the square root of x. So it's really x squared of x. Okay, how close? It's kind of hidden in here what we're optimizing, but how close really means minimize the distance. You're finding the closest point possible. So we want to minimize the distance. In order to do that, you have to remember your distance formula. And the distance formula, if you remember, we'll write that here. The distance formula is the square root. You subtract the x-coordinates squared and subtract the y-coordinates squared. It came from the Pythagorean theorem. If you square both sides, you can kind of see the Pythagorean theorem built into this. Okay, we would like to minimize d. As you look over there on the right side of d, you see that square root. So let's just do one step further. Instead of minimizing d, let's just minimize d squared, and let's just call that our function. So if we square, we get rid of the square root. Let's just call it x1 minus x2 squared and y1 minus y2 squared. So if we think about that just for a minute, we wanted to minimize d, and d is right here. D is the square root. But how would you minimize the square root? And the answer is put the smallest thing possible inside the square root. So this part right here inside the square root, if you want to minimize the square root, put as small a thing possible inside the square root. So we end up here with this function without the square root, because that would make sense. You put the smallest thing inside the square root as possible, the smallest thing as possible, because you want to minimize what comes out of the square root. And notice I just forgot a square here. You probably saw it a long time ago. Okay, so we've got our formula here for f of x. And now let's plug in what are our points. x1 minus x2. Well, I've got the coordinates of this point. It's 3/2, 0. So I'm going to go x minus 3/2 squared. And then my y-coordinates, again, I'm looking up here. I know the y-coordinate for that point is the square root of x. And very nice that that y-coordinate is 0. We would have had an algebraic mess if that was something else and we foiled that out. But luckily here, with a 0 in there, the algebra is not going to be quite as messy. Okay, no calculus yet. Let's just do a little bit of algebra. I'll FOIL this out, and it looks like an x squared minus a 3x plus a 9/4. And look over here, the square root of x squared is just another x. Combine like terms, I'm losing a little space here, so I'm going to write it over here. So we get our function that we want to minimize is x squared. Looks like it's minus 2x plus 9/4. Okay, let's find our max or min. To find our max or min, we're going to take a derivative. To find our critical points, we'll see whether the derivative is 0 or undefined. And our derivative looks like 2x minus 2. That's defined everywhere, so I'll set it equal to 0. And a fairly easy problem to solve. Looks like x equals 1. So truly we are moving a little bit to the left as we find that minimum distance. Is that really a min? I don't know. Let's take the second derivative. Second derivative is 2. The second derivative is positive, meaning my function, the graph of my function is concave up. Or by the second derivative test, I truly have found a minimum. By the second derivative test. And that was our only critical point for our function. And since it's a minimum, that has to be the absolute minimum. Now let's go back up and make sure we've answered the question. How close does a curve come to the curve y equals square root of x come to the point? Okay, so how close? They weren't really asking for the point. They're asking for how far apart are the 2 points. So let's get our point. We had x equals 1. We know our y coordinate was the square root of x. So the square root of 1 is 1. So one of our points is 1, 1. Our second point is 3/2, 0. And now we can just use the distance formula. So how close does the curve come? Well, it's going to be the square root. We'll subtract our x's squared. We'll subtract our y's squared. And let's see what we've got here. 1 minus 3/2, negative 1/2. If I square it, I get a 4th. 1 squared is 1. So it looks like 5/4, square root of 5/4. And if I simplify that, how close does it come? It comes the square root of 5 over 2. Let me write that just a little bit neater. So it's the square root of 5 over 2 units is the minimum distance between the curve y equals square root of x and the point 3/2, 0. That completes the problem.